Okay, so a little bit of clarification on this mole terminology. There are a lot of words that are very similar, and there are subtle differences. In the video by Tyler DeWitt, he glosses over some of these and just says they're the same thing, and he's right in a lot of cases, but there's some important differences that I want you to know. So first off, when you look at the periodic table and say we're looking at the element carbon here, we have a number, well, elemental symbol. I forgot to include the atomic number up here. It would be atomic number 6. The number down here, this 12.011. So this number here with the decimal places, okay, this is the atomic mass or the atomic weight. This is the weighted average of all naturally occurring isotopes of carbon measured in atomic mass units, or AMU. Atomic mass, atomic weight, those two words are interchangeable. So, as again, I forgot to include up here the atomic number. That's the number of protons in the nucleus. Carbon is element number 6. It has 6 protons in the nucleus. An atom with 6 protons in the nucleus is identified as carbon. So that's the definition of carbon. The definition of atomic mass or atomic weight is the weighted average of all naturally occurring isotopes of carbon. So if you remember way back when we talked about isotopes, carbon is, most carbon is carbon-12, but about 0.1% is carbon-13. So it has 6 protons and 7 neutrons. Well, our balances in the laboratory do not measure in atomic mass units, and furthermore, if we're talking about a single atom, we can't really do a whole lot with a single atom. This is the mass of a single atom in atomic mass units. So instead we have the molar mass. The molar mass is the mass of 1 mole of any substance, in this case carbon, measured in grams. So if I have 12.011 grams of carbon, I know I have 1 mole of carbon, or 1 Avogadro's number of carbon atoms, or 6.02 times 10 to the 23rd carbon atoms. So the molar mass is what we use in the laboratory because our balances measure in grams, and we can essentially count by weighing. If we weigh out 12 grams, I know I have 1 Avogadro's number. Now there are a couple other terms that are frequently used. One is molecular weight. So what is molecular weight? Well, it's similar to atomic weight, but it's for a molecule, right? So we're not going to just deal with elements like carbon or iron or something. We have molecules such as water, H2O. The atomic weight of oxygen is 16. Hydrogen is 1 atomic mass unit. So 16 atomic mass units for the oxygen, 1 atomic mass unit for each of the 2 hydrogens gives us a molecular weight of 18. So it's this, the molecular weight is the sum of the individual atomic weights in a compound. All right, so that's what molecular weight is. But you know, some compounds are not molecules like water. So what if you're dealing with something like sodium chloride? We talked before about how there's a difference between covalent and or molecular compounds and ionic compounds. So something like sodium chloride does not exist as a molecule, so it's a bit incorrect to refer to it, its molecular weight. Therefore, we have this other term, formula weight. Formula weight, similar to molecular weight, but this is for any compound, and it's simply based upon the chemical formula. So even if we're not talking about a compound that exists as discrete molecules, we can still calculate the formula weight. And formula weight and molecular weight, they're essentially the exact same thing, except these are for compounds. Atomic weight, atomic mass, those are exactly the same thing, but those are for elements. All substances have a molar mass. The molar mass is the only one that's measured in grams per mole. The rest of these are all in atomic mass units. So I hope that helps clarify a few of these terms.